This video is for Homework and Mastery 4.1, Section 13.1 in your textbook, Removing a Common Factor. What we're doing here is we want to look at factoring out our numbers and variables, and then being able to factor out in polynomials. We want to remove our common factor, or what we also like to call our greatest common factor. When we look at a number, a variable, or algebraic expression that gets multiplied together, each term that's multiplied to produce that term is called its factor. So when we're asked to factor out a term in our polynomial or expression, what we're wanting to do is factor it into anything that would multiply to give us that. So for example, 15xy, we want to factor out 15 into the numbers that multiply to give me 15, which are 3 and 5. And then we have times x times y. So what we're doing is we're wanting to factor out anything that is common and put our remainders or leftovers back in the parentheses. So let's look at 15x minus 5. What I want to do is I want to look and see, is there anything common that will factor out of the 15 and the 5? And then is there a variable that is the same in both? Well, where I think about 15 and 5, both of them are divisible by 5. So I can factor out a 5. When I do so, 15 divided by 5 leaves me with 3x. 5 divided by 5 leaves me with 1. So factored form of 15x minus 5 is the same thing as 5 times 3x minus 1. I can always check myself by doing the distributive property. I can say 5 times 3x, which is 15x, and 5 times a negative 1, which is negative 5. So I have factored this correctly, and this is my factored form, 5 times 3x minus 1. Let's look at this example, 12xy plus 6xz. First of all, is there a number that will go into both 12 and 6? 2 will, but I want the largest possible number. That would be 6. Now, are there any variables that are common in both? The x. So my common factor of 12xy plus 6xz is going to be 6x. When I take 12 divided by 6, that's 2. I factored out the x, so I'll just be left with a y. 6 divided by 6 is 1. I've taken the x out, and I'm left with a z. Remember that 2 is also a factor, but we want to look at the greatest common factor. And again, you can always check yourself by saying 6x times 2y gives me 12xy, and 6x times z is 6xz. This is why we went over the distributive property in the previous unit, so that we could start looking at factoring. When we want to factor a polynomial with common factors, first we determine the greatest numerical common factor by asking what is the largest integer that will divide into the coefficients. What number will go into both numbers? Then we determine the greatest common variable factor. What variables are common? We have to use the smallest exponent of each variable that is common. The common factors are the first part of the answer. After removing the common factors, what remains is placed in the parentheses as the second factor. In other words, we put the leftovers back in the parentheses. So for example, if we look at 36a to the 6th plus 45a to the 4th minus 18a squared, we want to ask ourselves first, between 36, 45, and 18, what number will divide into all three of those? The largest number that will divide into all three of those is actually a 9. Then I look at my variables, and I have a to the 6th, a to the 4th, and a squared. Remember, when you're looking at the variables, you have to take the smallest exponent. So we're going to take a squared. So my 9a squared is the common factor. Whenever I divide 36 by 9, I'm left with 4, and I've taken a square out of the a to the 6th, so I'm only left with a to the 4th. 45 divided by 9 is 5. I started out with a to the 4th, but I divided that by a squared, so I'm subtracting their exponents, and I'm left with 5a squared. Negative 18 divided by 9 will give me negative 2, and the a squares, wherever I divide, will actually cancel out. So my factored form of 36a to the 6th plus 45a to the 4th minus 18a squared will be 9a squared times the polynomial 4a to the 4th plus 5a squared minus 2. Again, make sure you check yourself. Check yourself by distributing. 9a squared times 4a to the 4th gives me 36a to the 6th. 9a squared times 5a squared gives me 45a to the 4th. And 9a squared times a negative 2 gives me a negative 18a squared. Look at 8x to the 3rd y plus 16x squared y squared minus 24x to the 3rd y squared. First question is, what number will divide into all three of these? Well, an 8 will. Are there common variables? Well, there's an x in every single one of them, so I take the smallest exponent of x. The smallest exponent of x is x squared. Then I look at the y's, and the smallest exponent of y is y. So my greatest common factor for this polynomial is going to be 8x squared y. When I divide out, 8 divided by 8 will leave me with a 1. X to the 3rd divided by x squared leaves me with x, and y divided by y cancels out. So my first term is left with just an x. 16x squared y squared divided by 8x squared y. 16 divided by 8 leaves me with 2. The x squareds cancel. Y squared divided by y leaves me with a y. Negative 24x to the 3rd y squared divided by 8x squared y. Negative 24 divided by 8 leaves me with 3 and negative 3. X to the 3rd divided by x squared leaves me with an x. Y squared divided by y should leave me with just an y. That should just be raised to the y power. So my final answer should be 8x squared y times x plus 2y minus 3xy. Looking at this particular problem, we have 9a to the 3rd b squared. What number is common to both? Well, that's our 9. We look at our a's, and we see that our smallest exponent of a is 2, and the smallest exponent of b is 2. So our greatest common factor is 9a squared b squared. When I take out 9a squared b squared from the first term, I'm just left with an a. Whenever I take out a 9a squared b squared from the second term, I'm just left with 1. And remember that you have to be able to multiply these back together to get your original problem. So if you factor out the entire thing, you always must leave a 1, because what is 9 divided by 9? It is 1. So we always have to leave a 1. So in factored form, 9a to the 3rd b squared plus 9a squared b squared will become 9a squared b squared times a plus 1. Let's look at one more problem, and that is 6 times 3x plus y minus z times 3x plus y. Now remember that my terms are the ones that are separated by the plus or minus sign. So this is all a term, and this is all a term. What is common between those two terms? Well, it's actually my entire parentheses, 3x plus y, because I have 3x plus y in both. So my greatest common factor is going to be 3x plus y. Whenever I factor out a 3x plus y from the first term, I'll just be left with a 6. And whenever I factor out a 3x plus y from my second term, I'll be left with a negative z. Since I have a plus or minus sign in my factor, I must put it in parentheses, just like it is in the original problem. And then remember to always put what is remaining in a set of parentheses. So in factored form, I have 3x plus y times 6 minus z. Remember that when you factor, you can always check yourself by multiplying items back together to see if you get what you started with. If you didn't, you probably made a sign error or did not get the correct exponents out. Make sure that when you're factoring, you take the greatest common factor, because you don't want anything left over to be the same in any of your parentheses. If you need help, please let one of us know.